This is Michelle DiPalma, Principal Solutions Architect, and your host of the Data Services Open Data Foundation Office Hour. I am here with Daniel Parks. Thanks for coming back. And special guest, Stephen Wilson. Hello, everyone. Hey. So this shows a little different than some of the other things we've talked about. Do you guys want to introduce the concept for today's show?
Yep. So the idea that we had is just sharing a little bit how can we deploy ODF, that data foundation, using a little bit like the GitOps approach, with the help of Argo CD as the tool to do the deployment, and just compare a little bit the traditional way of deploying ODF with this new approach, that could be using GitOps. And the idea was for Stephen to give a brief introduction into how we have applied GitOps to deploying ODF and doing also day 2 operations. And then we have a demo where we can show a little bit how it works and give an explanation on the things that we have made, not just as an example really of using GitOps with ODF.
Yeah, sure. Talk about the manual deployment method that we've traditionally used, as well as the infrastructure as code deployment method, where we're using the GitOps methodology to, produce the infrastructure that we're going to run these workloads on, especially inside of OpenShift. Just recapping, most times the manual deployment involves deploying the ODF operator from Operator Hub, and then we manually go and we label, and sometimes we taint the ODF nodes that we're going to use. And then we also go and we either use the UI or the command line to add the storage cluster to the OpenShift cluster. Well, with the GitOps method, we establish a desired state, and then we use OpenShift GitOps or a GitOps controller, some type of controller, to take that desired state and make it so in the cluster, and we reach our final state is what we want. And that's typically managed by PRs and merges from different branches to a main branch that the cluster uses to deploy the infrastructure that is composed of. What that typically looks like is you usually bootstrap an OpenShift cluster, and then we add in OpenShift GitOps, more commonly called Argo CD, and we point that to a Git repository. And then from there, the Argo CD instance monitors the applications that we've deployed within the Argo CD deployment, and it monitors those and watches for changes and syncs the cluster with the changes that have been pushed into the Git repo. And management of the cluster from then on is either through pull or push PRs and making the cluster the desired state. And really, that's it. And the good thing about that is everything's logged and tracked, and it really helps with the security posture of the environment.
So, quick question. So the motivation for approaching it this way would be, you would capture absolutely all the customizations that you've done and that you want done repeatable. You can do this on any, so you've got it all maintained in your kind of GitOps Argo CD pipeline. You don't have to go back in and do anything later. So if you lose a cluster or you're migrating clusters or whatever you're doing with something fresh or new, you can go back to and restore this state. Is that
correct?
Because my initial thought was like, why would we do it this way? And I'm like, well, I guess you've got a million little things that you've actually changed to your ODF installation that you may want to, keep track of. So sorry, go ahead.
That's true. And then also at the same time, from a security perspective, it allows you to see if the cluster is in line with your desired state. So Argo CD allows you to see that, hey, this cluster is not in sync. And then you ask your questions, why is it not in sync? And then that's when you can, you should have checks to constantly make sure that the cluster is in sync. And then if it's not, somebody has done something. And then you get security to work at it, to look at it and things like that. So that's another tracking mechanism, as well as, what you had said earlier about the just, manage the cluster through GitOps.
Yeah, that's what I was going to mention, because like when you have like this GitOps approach, really you have a repo, your GitHub repo that is the source of truth for the desired state of the cluster, and it can't be any other way. It has to be as you have it in that repo, and then automatically you are taking advantage of all the auditing and trailing that you have in Git, because you have a pull request where somebody has to say, okay, I want to make a change, and then somebody has to approve it. and you're going to have the time that when it was approved, so you have a perfect audit trail, no, of all the changes in your cluster. No, that is really a big advantage. Even as you said, Michelle, because maybe there are not so many things that you can touch or configure when you deploy an ODF. But then with day 2 operations, maybe you want to add more OSDs, no more space to your cluster. You want to enable, I don't know, for example, Rails Gateway or certain changes, no, that you want to do. Then you can perfectly follow the trail of who has modified it, when, and why. No.
Yep. How many times have something happened in the network or in the cluster, and everybody's asking, what did we change? When did we change it? Who did this and who did that? And of course, everybody's saying, not me, I didn't change anything. Well, that's why we got that Git history to say, no, you did increase the size of the ODF cluster and it wasn't approved.
With a comment, no less, a reason why you changed.
Yeah, as long as you got a good reason, you're good to go.
Okay.
Yeah.
Yeah.
So do you want,
yeah,
go ahead.
I was going to say, typically, one thing going further with it, typically, when we implementing the solution, there's two really popular methods, using customize and using Helm charts to add these repos and manage the state of the cluster. And Daniel's going to go through and show you, an example of those, and also the kind of structure. A recommended structure or one way of doing things for managing the cluster with the ODF cluster with the GitOps method.
Daniel, you're going to share your screen? Do you
Yeah.
Okay.
I will share my screen just a second, the full entire screen. Can you see that okay?
Yep, coming through clear.
Yes, perfect. Well, I just have a couple of slides, but it's really to explain a little bit what we are trying to achieve in the demo, no, that we're going to show today and that we're going to go through, just to give a little bit of context to get us going. So the idea or the goal that we want to achieve in the demo today is get ODF deployed using the GitOps approach, as we mentioned, with the help of Argo CD that is going to sync the desired state of our ODF deployment. And then we want, as a destination, no, we want to deploy in 2 different clusters. We want to deploy ODF in a cluster that is production and in a cluster that is development, no? And we also want to have different configurations in each of these clusters, so that really when we want to apply those different configurations, we want to tinker or make different configurations is when, as Steven was mentioning before, you have different ways in which you can render or generate or modify these objects that you want to apply to your cluster, not the desired state. In this case, we can see here in the left that we are going to have our source of truth, as we explained, a Git repo, no, that is the one for Argo CD. And that Git repo, the contents of that Git repo is going to be a Helm ODF chart, a Helm application, no, that we're going to go through in a second, and I can show you a little bit how it is structured. And once we have our Helm application, we are going to use Argo CD, and in this case, Argo CD ApplicationSets, to get automatically deployed the desired state of our ODF deployments in both of our clusters, no, the production cluster and the pre-production cluster. Just very briefly to mention, in Argo CD, we have the concept of an application, but an application has a source and a destination, but you can only configure one application per one Argo CD cluster. Now, with application sets, the advantage that it has is that with an application set, you can configure several clusters, no? So you are going to deploy the same application on X number of clusters, no? Using a template that we are also going to check in a moment. So it's very powerful and very easy to use. And it's a really good tool to, from one single place, be able to deploy X number of clusters. In this case, we're going to deploy ODF. The last slide that I have here, and it's just to get you through a little bit what will be the workflow of the demo that we're going to follow, is first we need to have Argo CD running, as you can imagine. No, we need to have the OpenShift GitOps instance up and running, I have already completed these steps for the sake of time, no, otherwise the demo would be too long. But I'm going to show you anyway how what it looks, no, when it's running on the cluster. So we go through that. This is the part that we have here in the left, and the steps that I have gone through is really deploying the OpenShift GitOps operator. That automatically deploys an Argo CD instance. And when that Argo CD instance is running, we have configured a repo and a project that I will show you now. No, the repo is going to be our GitHub repo, our source of truth, and a project is an Argo CD project where we define or we set certain rules for our source and destinations. No, and I will show you that in a moment. And then I have also added the production cluster and the pre-production cluster to Argo CD as clusters, no? So we can manage them and we can also configure applications on them. I will show you this in a moment. And then what we are going to actually do, no, during the demo is the actual ODF deployment. And we're going to go through these steps that we have here that I'm going to briefly mention as we go along, no? So do you have any questions, or shall we begin going through the demo?
No, dive right in.
Yeah, let's jump right on in.
Okay, so because we work with Git, no, and Git is our source of truth, we need a Git repo, and I have already cloned the Git repo that we will also leave on the link, no, on the notes of this recording of this video. But you can see here that I have already cloned the repo, and I have here.
Can you make your font a little larger, just for
Yep.
the visually impaired like me? Thank you.
Yes, that's a good point. Is this better, or?
Yeah, I think that's good. Okay.
Great, thank you for that. So let me just clear this. Yeah, so here we have the ODF Helm chart or Helm application, no, that we are going to use. And let me just show you a little bit the structure, no, of this folder that is our actual application. Here we have a chart YAML file. This is a standard for Helm applications. In the chart, you normally set metadata, like who's the maintainer of the chart of the Helm application, if it maybe has any dependencies, prerequisites, some things like that. No, then we have the templates. This is another folder, and inside the templates folder is where you have all of the objects that we want to apply to deploy ODF. No, so you can see here that, for example, we have the namespace, we have the operator. So all of these are the objects that are going to get applied. And then we have values files. No, these values files that I'm going to show you just in a moment, and we're going to modify, are where we specify the parameters that we want to set for each of our clusters. No, so let me go into one of these value files, for example, for development. Sorry, let's go. Set here ODF. And as I said, this is just an example chart that we have put together for the demo, no? It's to give an idea of what you can do, but it doesn't mean that you have to do something exactly like this or maybe even close to this. No, you can do whatever you like depending on your necessities. No, but this is just an example that maybe can get people going with this kind of example. So with this charts, thing that we can configure, for example, is our version of ODF. We're going to use ODF 4.9 because our OCP is still configured in an OCP version 4.9 that I will show you right now, just in a moment. We can also configure the requests and the limits for all of our ODF services that we're going to leave them as they are. We can also configure here if we want to have Rails Gateway enabled or disabled, multi-cloud gateway, our Ceph tools. So let's, for example, because we have to make some changes, no, let's, for example, enable the Ceph tools. Sorry, let's set this to true. And the Ceph tools is just a small pod that gets deployed. When ODF gets deployed, you get this small Ceph toolbox that you can exec into, and it will give you a shell into Ceph that is really nice for troubleshooting issues. No? So let's say that we want to have that in development deployed. Also, in this chart that we have written for ODF, if you are running in AWS, you can select if you want to have dedicated ODF nodes. No, if you set this to true, that we're going to do it in production, you will get worker nodes deployed for you. So using a matching set, an OCP matching set, you will get 3 worker nodes deployed, and they're going to be used as dedicated worker nodes for ODF. No, when this is enabled. Let's say that for pre-production, we want to save resources, so we're just going to use our standard worker nodes that we have running, and we don't want to enable dedicated nodes. And here we have the configuration of the storage cluster, no? So the number of OSDs, if encryption is going to be enabled, the number of replicas. This is the storage class that we're going to use. So this is a storage class from which our OSDs and our persistent volumes are going to be created from, and also the disk size. No, let's say that we are running a development cluster. We want to save resources, and we're going to use only 512 gigs for our OSDs, no, as the size. So that would be the configuration that we have for our development cluster. And let's go a moment into production.
Can I ask you a quick question? Are there, I mean, from what I remember, that pretty much looks like everything you do on install when you go through the operator kind of UI path. Is there anything missing? Are there any limitations to doing it this way?
No, not really.
Okay.
No, that's a good question. There's no really limitation. It depends on how much effort you put into your Helm chart, let's say. No, so this is something that we have for the example that is quite you have quite a lot of options. Maybe there are some things missing here, like for example, deploying with a logical storage operator, no, deploying with LSO, that could be added. But you can get as creative as you like, and everything is going to work, so that you are not going to miss anything. The only thing is depending on the effort that you put on your Helm chart, no, to be as rich as possible.
Yeah, and I would say that's the benefit that Helm has over the customized version, is that within the Helm chart you're able to make decisions based on what the current cluster looks like, as well as decisions that you're able to make through the variables that you instantiated. Like Daniel said, the decision could be, if you're on AWS, then use these variables. If you're on vSphere, use these variables, and all of that is in the Helm chart. And Michelle, there's also a great benefit also that the CLI has over the UI, and that is there are some parameters that we're able to change on the CLI that you're not able to change within the UI.
Right. The toolbox, I think maybe my information is all, but things like the toolbox are always CLI, right, and what have you. Okay,
yeah,
so
toolbox, the different sizes of the disk that you use. You can change that from the CLI, whereas in the UI, you have the 3 different options that you have. But yeah, there's a lot of changes that you can make, just like Daniel's showing here, the memory request and the limits that we have. You can change that on the CLI. And then also some of the components that you do not want to deploy, like he had enabled, is true for some things, like he's showing here now for the RGW being enabled, or as well as the multi-cloud gateway being enabled or not enabled. Those are things that you would change on the command line in your storage cluster CR that eventually gets deployed by the the Helm template engine. And usually what that looks like at the end of the day is simply an OC apply.
Okay, so quick question around this, and I don't want to get too much into it because I know you have good stuff to show us. So let's say, is there a convenient way to dump your current state? Let's say, you're a new admin, you walk into some place, it's got ODF already. I want to dump this state so that I can then put it in GitOps and follow this. Is there an easy way to do that? Or are you going to end up, going through the command line, looking at this and looking at that and those parameters? Is there any transition path there
so
you know what I mean? If you were looking at something, you didn't know what was going on because you didn't set it up. So you want to know what's the fast path to this.
Yeah, you have I think 2 ways of going around that. No, you could go and look the actual chart that we are looking at here, and then you have all the options and you have the latest version, because you are going to go to Git, no, and you're going to get the latest commit that is available, and you can also render the file. So I will show you that afterwards, but what we are doing here is we are setting a certain parameters, certain values that then they're going to be pushed into the actual YAML files, that are our YAML files with our objects to deploy ODF, to deploy multi-cloud gateway, whatever. So even if someone gets a little bit lost with these parameters, there's a way that you can do a dry run, let's say, and you can render all of the parameters, and you can take a look and see what they actually look like, and then you could take a look at that. And on the other hand, we're also going to show you afterwards that the Argo CD has a UI, and you could also go into Argo CD, and you're going to see all the objects that are created, and you can take a look on the different parameters, and you could also check from there that we can see in a moment also.
Okay, awesome.
Yeah, and also OC Describe is your best friend.
I was just thinking because ODF is it has a lot of parts. You have to get into all the parts. So okay, so continue, please.
Yeah. So I went into the production. I will just wait a moment. We did pre-production, so we have, let's say, the options that we want to apply for our development cluster ready. Now we are going to modify production. Now that we want to, let's say, change certain things, like for example, let's say that because it's in production, we have more resources and we want to set the limit for our OSDs higher because they're going to give us better performance, not just as an example. Let's say, again, let's enable the chef tools. That is always a good idea. And then here I wanted to use the dedicated nodes. Again, what it's going to do is going to get a matching set, and it's going to deploy 3 nodes for us in AWS, and it's going to label them, and it's going to get them ready for use with ODF. The only thing that I need to do here, just a moment, is get the cluster ID from the cluster. So let's just run this command.
Oh, you just have to quote, yeah.
Here we go. Okay, so we go back into our file, and I just have to change this cluster ID because it needs it for the matching set to work. Now the region and the AMA file is exactly the same, so we don't need to change that. Let's say that the encryption is true. We can leave that set. And as you can see, we are using bigger drives now because we are working in production. And let's say that we need more space, so we're going to leave 2 terabytes per OSD here. Okay, so we have modified our files. Let me clear this. For example, if we do a git status, we can see what has been modified for the moment. Now that we have modified these 2 files, the development and the production cluster. So now what we need to do is actually push them to our Git repo. No? So I'm going to, this is a standard Git commands now. I'm going to do a commit where we can set a commit with a comment like you just mentioned before, where we say values for ODF. Example, and now let's push this to our upstream repo. No? So this is going into GitHub and into the upstream repo. Okay, so we have made our modifications. They are in the upstream. Now, the next thing that we want to do is actually work with Argo and create these Argo CD applications now with this Helm chart that we have. Just let me show you a moment. Where are we running? So you can see here, OCGet cluster version. So as you can see, this is like a 4.9 OCP cluster. And we have an instance of Argo CD already deployed. So the only thing that has happened here is that the operator has been deployed, and it has configured an Argo CD instance. As you can see here, we have a controller for the application and also for the application set. So we have Argo CD running. And then I have also, I'm going to use for this part, the Argo CD CLI, but you can, we are also going to see how you can do it on the UI, but just let me show you this Argo CD that we have created a project. This, as we mentioned before when we were going through the slides, an Argo CD project is not an OpenShift project. This is part of Argo CD. And really what you define in a project is like you're trying to set limits on the destinations, that the destinations can be on which clusters, on which namespaces I can deploy an application, and also the sources that are available or that are permitted for this project. And in this case, you can see that we are using our GitHub repo Okay, so that's the project that is ready. We can check that we don't have any applications deployed for at the moment. And the other thing that we did is add the clusters. No? So as I mentioned before, you can see here that we have the development cluster where we want to deploy ODF, and we have the production cluster with their URL no, to the API already configured into Argo CD. Next, what we need to do is use an application set to actually get our applications, no, our Argo CD applications deployed. For that, normally when we run this with automation, it will normally all of it get deployed, but I wanted to automatically, you know, but I wanted to run it manually, so you can also take a look at what it looks like now. So going into what we were mentioning before, when we said that we could render the files, no, this is the command with Helm that you can use to render all the variables that we have in values into the actual objects that we have inside the templates. No, so what I'm going to do right now is render all the values for the application set that we are going to use for Argo CD. And you're going to be able to see it now, because this really generates files for us in this folder. But we're going to need, because there's some strange space there, so let's go manually through it. Let's clear this. And really what I wanted to show you is the application set that gets created. No? So this is the our application set, and this is the application set already rendered for us. No? So when you were mentioning before, Michelle, if there's a way to see what the state looks like, you can use the Helm template command that I just ran here, and you will get the rendered version. As I said, normally this will be done also through Argo CD, the creation of the application set, but I wanted to just run it manually so we can do an OC create and see what it looks like.
And you can see within the template, within the application set file, how the templates will be instantiated, just like regular templating in Ginger templates.
Okay.
Yeah, here with application sets, how more or less the idea behind application sets is that you have a generator and you have different types of generators. Here we're using the simplest one, the easiest one, no, that is really a list of elements that we want to get deployed or defined in our template. No, that I will go through that now in a moment. But if you take a look, we have a list of elements, and what we have in a list is the clusters to which we want to deploy our application. So this is just a list where we would enumerate all of the clusters where we want to deploy. No? As you can see here, we have cluster pro and cluster dev that are the same clusters that we have configured already in Argo CD as we mentioned before. No? So what you have is a generator with this list of elements, and then that list of elements is going to be applied on this template. No? So really what it's going to go through is in a loop, and it's going to apply wherever you have the cluster variable, is going to apply what is defined in your list of elements. No? So really here we are generating Argo CD applications, no, on the fly. So let's say that from the template onwards, we're generating Argo CD applications on the fly. And what's an Argo CD application, as we explained before, is a source of truth in Git and a destination where Argo CD has to automatically sync the state. No, and as you can see here, yeah. Sorry, go ahead.
Michelle, I need to jump real quick. How do you want to handle it?
Will you be able to come back?
I will.
Yeah. So you can jump off and then come back when you're ready.
Okay. I'll jump
back. Perfect. Yeah. So what I was mentioning, so you have like the source. Really, and a destination. The source is where is our GitHub repo, what type of application that we are using. So as you can see here, we have source. The kind of application that we are using is Helm. What is going to be our value files? That, as you saw before, our value files is really where we are configuring all of the parameters that we want to use for ODF, where you can see here that we have values, and then the variable is going to be applied for each of the ones that we have in this list. That if you remember and we take a look here, I can just very quickly show you here Argo CD ODF. So as you can see here, the values files that we have here really is going to get converted into this one and this one. So that's really why we have that defined here. So
quick question. So just make sure that for everyone listening to get this straight. So we are using Helm to then we're going to deploy a Helm chart, which is going to configure Argo CD to have a project that's going to have a destination of either whatever we put in the list there, and then go and apply all of the values that we've told Argo CD to apply. Is that the management change? And to hold all of this information, we have that in a GitHub repository.
Yeah, that's correct.
Okay.
No.
Okay, just checking because I'm not a GitOps person yet, so I just want to make sure I have like the whole workflow. Then I'm like, oh, okay. Okay, so go on.
Yeah. You can do this in many different ways, because there are, let's say that there are people that use different repos, one for Argo CD and the management, another one's for the applications. You can have everything in the same repo, but then use folders. You can have everything in the same repo, but then use branches for different things. So there are many ways of going around this. And in this case, we're using the same repo, but we're using different paths. So we have a path that is ODF, where we have our Helm chart, our ODF Helm chart. But then we have another path that is Bootstrap, where we have all the information about Argo CD and how to deploy Argo CD. So we are really differentiating one from the other by the path. But there's not a good way of doing this. Everyone can choose how they prefer to go around this, and it's perfectly fine. So as we were mentioning, we have a source that is our source of truth with our repo, our path, as you can see here. And also, if we have a branch, that is the target revision. In our case, we also have the application set branch. But this really what we're defining here is the source of truth. Where is the state of the application that we want to define, and all of this is in the source. And then we have destination. That is what you were just mentioning before, Michelle. That is where do you want this applied? You have to tell me where do you want to apply this. And as you can see here, we're going to go through the list of elements, and we're going to change the destination name to cluster pro and cluster dev. So really, we're going to get in the end 2 applications deployed, one in the production cluster and the other one in the development cluster. The only thing is that because it has specific values, the advantage that we're going to get is that we're going to get different configurations for each of our clusters. Okay, so let's just do a standard. Let me make sure that we are in the right project, in the right namespace, OpenShift GitOps. So I'm just going to do OC create the application set. And what is going to happen here, if we maybe are quick to take a look, we can check. As you can see, we have a controller for applications and a controller for application set. So we can take a look at the logs for the application set and see if it actually did its job. And as you can see here, well, maybe it's a little bit difficult to see, but I just wanted to mention in case people have issues when trying to debug this, that with log to the application set controller, you get quite a lot of information as an error. Here, everything went fine. And as you can see, we have a cluster pro ODF application deployed and a cluster dev ODF. I'm going to show it with the actual Argo CD this command, where you're going to see it much better. So what happened really with our application set is that automatically it deployed 2 applications. One is called Dev ODF and the other one Pro ODF. The big difference that it has is that it's going to be deployed to different clusters, to different destinations that I'm going to show you just in a moment. The other thing that I wanted to mention is, as you can see, the state of the application is out of sync. Why is it out of sync? Because we have a state that is ready and waiting for us on a Helm chart, and it hasn't yet been applied to our destination clusters. So our destination cluster and the source of truth, our GitHub repo, are out of sync. You can configure this to, as soon as the application gets created, you can configure it to start syncing. But here, maybe because in production for caution, you want to leave this disabled and do it manually. Maybe not. Maybe you want to have it automatically set. Here we have it. We have to press the button automatically. So I could also show you the UI, when it starts the sync. So let's move into the UI. Now I will make it bigger. Let me get the password. Just a moment. Yeah, here what I'm doing is I'm extracting the secret from the OpenShift GitOps cluster secret that is inside the namespace, and I'm going to use it to sign in. It's true that with the OpenShift GitOps, you have the DEX server that is able to authenticate using OpenShift users. So we could perfectly log in via OpenShift and use a user from OpenShift, from our actual OCP cluster. Let me make this bigger. Otherwise, is that better? Can you see that?
Yeah, no, this is great.
Okay. Oh, okay. So again, this is just the same view, but a little bit nicer that we had in the CLI. We have our dev application and our production application. As you can see, the big difference, the destination, one is dev and the other one is pro. So we have our two clusters. Let's go ahead and sync this. One thing that I wanted to show you before I start the syncing is what we were speaking before about the audit trail. As you can see here, it's mentioning that it's out of sync, and it's saying that the source of truth is this commit from our GitHub repo. If I press here, it will take us directly to our GitHub repo, and we can perfectly see that it was me. If something goes wrong, it was my fault. That 14 minutes ago, I made two changes to the development cluster values file and to the production cluster. And we can also see what we actually changed here, in this part. So as you can see, it's great also for seeing who made changes when, and what did they change. Okay, so let's give this a sync.
So
here
syncing actually says go apply these differences, right? That you're actually kicking it off. Okay, and you mentioned that could be done automatically, but in this case, because you want to show us we're doing it manually. Okay.
That's completely right. This step that I'm doing now, that I'm pressing synchronize, you can set that when you're defining the application to be automatic, and then you wouldn't have to do this step. So as soon as the application gets created, or as soon there's a change on your GitHub repo, it's going to be applied to your application.
Okay.
And once I fire it off, as you can see here, it's really starting the deployment. The first thing is going to go and start the ODF operator, and it's going to go through all the steps that you will normally go to deploy ODF.
So I just remember from before. Maybe it was for production. The machine sets, it has to grow. Is that the production cluster?
That's a really good point. I wanted to mention that, so it's a really good question. And as you can see here, that's the main difference. That you can see that we have here the matching sets of objects that we didn't have in development. So we have that ready to get deployed here.
Okay, so and we have that listed as a dependency somewhere. Like wait until these are. I don't remember seeing it, but you have to wait till they're done to do it. So okay.
Yeah, that's another really good question, and you're reading my mind. We are going to speak about that because that's a little bit an iffy or a little bit complicated way of doing things. And I will go. Let me sync it, and once we start syncing, because it takes a while, we can speak about that because it's a really good question what you just mentioned. I wanted to dig a little bit deeper, but as you said, you can see here that the first thing that needs to get deployed is our matching set, and in turn also our machines that are going to be the workers that we're going to use for our dedicated ODF workers. So going into the topic that you just brought up, that is a great topic. How do we orchestrate all of this? Because really, if we have a small application where you have, I don't know, a deployment and some pods and it's something easy to manage, okay, that's fine. No, you really don't have to go into all of these details. But if you're working with something complex, like it can be like ODF, for example, where you have an operator. We're also deploying infrastructure, as you can see here, that we're deploying new machines before deploying our actual ODF. So there are a lot of steps that need to follow an order. Otherwise, they're not going to work. And let's say that Argo CD provides us with tools to work with this. So you can give an order to which your objects get applied. And I'm going to show you that straight away, how we do that while that gets deployed. So we have, this is the same repo that we were working for before, no? And we have ODF that I mentioned before. And if we go, let me just show you this. Let me just do it clear so you can see a little bit better. So what we have is sync waves. So that they're called sync waves, and it's just a way inside Argo CD to give an order on how our objects are applied. So how it really goes is that it's an annotation that you set in each of your objects, and then you give it an order. No, the negative numbers are the ones that go first, and then we go onwards. No, so for example, here you can see that with -1 we have the matching sets. No, they have to go first. Then we also see, for example, with number 0 that we have our operator, and also we have the actual ODF operator that I was looking at. So the subscription to get the operator deployed. Then on the next step, for example, we will get actually our storage cluster. Now that this is when Ceph gets deployed. So as you can see, there is a way to give an order to how you want all of these objects applied.
So the order is kept in SyncWave, but could you take me back to where was the decision making about, oh, I'm on AWS, this is how I make a machine set? Like that was, I know you showed it already, but I just want to.
No, I didn't. It was brought up by Steven that he mentioned that, and let me show you an example because just let me show you where we have it, and if we deploy with a gateway. Maybe here I have an if. Yeah, so just as an example, because I'm not sure because this Helm chart that I have right here is, yes, I know where I'm going to show you. But as you say, how you work with these templates is you have your normal object, no? Like this is a normal Kubernetes or OCP object, and then like you will do with your Jinja templates, you have all kind of ifs, when, else if, no? So you can modify or do all the things that you could need to give it a little bit of logic inside the templates, no?
Okay, so that's your Helm templating part, making those decisions, helping you make those decisions. Okay, I'm just trying to separate it in my mind. Okay, like so for decisions, you're gonna work the Helm templates, and then for order, you've got the SyncWave piece. And okay, all right, okay, awesome.
Yeah, that's perfectly how you mentioned it. So as you can see, this is the for example, the machine set that I am using, no, the actual object. And as you can see, what I'm really have here, no, in my Helm chart is, if in our values file we have dedicated enable, then go ahead and deploy the matching sets. No, so it's really how this is done, no, at the Helm level. So Argo CD doesn't take part in this. Argo CD, the only thing that it does is that it's able to render all of these values that I'm setting in the Helm chart. No, he's able to understand them and then do the rendering to actually apply the object in the end. But as you can see here, for example, the cluster ID that we got, no, and that we set on the variable is also set here, no. Right, so it's really kind of a Jinja template approach that you will follow.
Okay, nice.
And then
you're going through stuff that I think I've done manually more times than I can count. You know what I mean?
Yeah.
Throw the machine.
Yeah, this is something because as you know, we have like our HPDS here in Red Hat, where you get an AWS lab, for example, but you get it for 4 days, 5 days, and then you have to give it back and deploy another one, and in the end you are deploying all the time around. No? So that's also what I use. I normally use this to deploy ODF, and I don't have to touch anything, and you get, as you said, your matching sets, you get your labels, everything in place, and you get an ODF running quite quickly and easily. So it's also a good fit for that as well. The last thing that I wanted to mention is, even if we have sync waves, everything is not as pretty as it seems with sync waves, because let's say that Argo CD is going to give the object as a health okay once it has been applied and it has responded with its health check of okay. No, so For example, for pods, you have health checks where the pod is running, but for different, let's say, CRDs now that you want to use, like for example, the matching sets, let's say that Argo CD, once it has applied and the matching set is created, it's going to say, okay, I have finished, move into the next step. But your machines are still getting deployed, no, they're being provisioned, they have to be added to your OCP cluster. So there are still some steps that is missing. And what I have done that is not pretty, to get around that is using what we call like wait pods, no? So let me show you one, just a second. So here, for example, so this is a wait pod that makes sure that the ODF operator is running. And what I do is using sync waves, I put the wait pod in the middle of, let's say, the deployment of the operator and the deployment of the cluster, because we want to make sure that the operator is ready. And really what I have here is an OC wait that is checking that all of the pods that are needed for the ODF operator are up and running before continuing into the next step. No, so that's why we're using wait pods. As I say, maybe this is not the prettiest thing to do. There are other ways to work around this. For example, you can use custom Argo CD health checks, where you could say, you could modify the actual health check and say, for this object, don't move forward until this and this condition is met. But that's a little bit more complicated. You can perfectly do it, but it's using Lua scripting that is quite complex in that sense. So that's another way of going around it. In this case, we're using wait pods. And the other thing that maybe we could do that I haven't explored yet is really using like a pipeline, using a workflow, maybe looking at Tecton or looking at Argo CD workflows, where you could say, okay, first, in the first step, deploy all my infrastructure, deploy all my machine sets. When that's finished, send an event, send a notification, or maybe if it's a pipeline, just go into the next step and then deploy the ODF operator, and go like that and give it an order using maybe Tecton pipelines, for example, or something like that. But I haven't gone or explored that deeply, but it's something that I would like to check if it will fit, to use it like that.
It's interesting. Okay, so that's definitely going to be, I can see using something like that when you've got like big pieces of infrastructure that you actually have to deploy. Do you have wait pods down the line anywhere, or is it just for the machine set?
I have two of them set. I have one for the matching set that we can see here. For machines, let me just make this a little bit so we can see it better. No, that's not it. Okay, I have this one for machines, and I have this one for the operator. Those are the only two that I have. Because afterwards, once you have the ODF operator installed, then everything else, you have already your CRDs, and everything else can be deployed at the same time. We don't have to actually have to wait for anything else.
Okay.
I will just bring it up just in case somebody also has this issue. This is going a little bit deeper more deeper than we wanted. But I will bring it up anyway. Let's say that Argo CD, when you do the first sync, like we press the button, it's going to check all of your objects, and it's going to do like a dry run and see if it can actually apply all of the things that you do before it actually starts syncing. And if it can't do something because maybe an object doesn't exist, the custom resource isn't deployed, something like that, is going to give you an error and it won't move forward.
Okay.
And that gives you, suddenly you have an issue, because let's say that when you deploy the ODF operator, that is going to create the custom resources for you. But if I'm doing the sync before I have applied the operator, those custom resources don't exist, and I'm going to get an error. And then when this option comes in, when you say skip dry run on missing resources true. So really, you are telling him, if this resource is not available, just skip it during the testing at the beginning and continue with the sync. So this is what we are mentioning here.
Okay.
Okay, so let's take a look and see how.
So this is the production. This is Cluster Pro, right? And then, where are we?
Yeah, let's check on the development. That should go a little bit faster. as you can see here, it's creating a lot of objects. There's a good thing that we have right now that it says that it has been able to sync. No, what it means when it has been able to sync is, okay, I have got the desired state that I have in my GitHub repo. I have now that state on the destination cluster, no, now
so it's
development
done.
cluster.
Sync here means finished, right? Like there's no more work for it to do. Okay, fantastic.
Yeah, the only thing is that for him, he has finished, but maybe regarding ODF, there may be, let's say, you are still waiting for the OSDs to go up, no, or something like that. He has already applied that that object, no. So for him, he's synced and everything is ready. But we can check very quickly and see how the development cluster is going. So let's do this, and let's do a Ceph cluster. It has to be OpenShift storage. Oh yeah, so this one has finished. No, our pre-production cluster created successfully. Health okay.
Health okay. Yeah.
Let me just make sure that we did things right, and we have a 512 gig. Oh, I always forget about the namespace. So as you can see here, for the pre-production, we have 512. No, that is what we selected. So everything is looking good. Let's go into production. This one takes a little bit longer because we're using the matching sets that we mentioned, but let's see how it's going. So it's configuring Ceph mons, no? So it's still working. Let's just the pod so we can see how it's being deployed. Okay, so it's looking good. No, it's doing its work slowly but steadily. It's going along. So it's working with monitors. After the monitors, we have the OSDs, and then it's going to finish. I wanted to show you. I don't know how we're going with time, because I wanted to show you, if we had time, how to do, let's say, a day 2 operation. That is, for example, adding Rados gateway.
Can you do it in like 8 minutes? Is it quick?
Yeah. Yes, I think that. I think that we can. Let's try anyway. If not, we will leave it running anyway. So
yeah.
So let's say that we want to make a change again to production, because, for example, we have a new requirement that we need to have object storage, no, and we want to deploy Rados gateway. That the Rados gateway is Ceph's S3 compatible endpoint, no, and we also want to use SSL because let's say that it's production, and also. Let's go ahead and say, okay, I'm running out of space. Let's add OSDs to our production cluster. No? So we have to make these changes. Again, this is on my local repo. I have to get that into our production upstream repository. No? So I have to, again, add commit, let's say here, adding RGW, just so we do it quickly. And we do it. Push. Okay, so this is a new push. We are going to have a new commit, a new version, and if we go into the production cluster, we can see this takes a little bit of time. We can hit refresh, or if not, it will actually check by himself that there's something different. But what has happened here? No, I have made a change in my GitHub repo, and then the cluster is saying, okay, I'm out of sync. No, there's something different going on here. And as you can see, the new object that is out of sync is, for example, our Ceph object storage that we just mentioned before. No, so now if I press sync, it's going to go ahead and deploy our Rados gateway, and it's also going to deploy our new OSDs, no, that we selected.
Okay.
The only thing is that before I actually apply this change, we need for the cluster to finish. So let me.
Yeah, I was going to ask you if we can do that. Okay.
Yeah. So this is production. No, let me just check that we're in production. Yeah. So it's everything is running fine. Let me just very quickly. OpenShift storage. I'm going to go into our Ceph toolbox now, so we can actually take a look. Well, let me run the sync, and then we can go into the toolbox. So this
And watch
we
it
can
happen.
fire.
Okay.
Let's fire this. So it starts deploying Rails Gateway and our OSDs. And now let's go into the toolbox. Again, open it. All right. Okay, so at the moment we have a new the cluster now. We can see that the health is okay, and for the time being, Rails Gateway hasn't been applied here. No, so
okay,
we can imagine that is here it goes. No, so we can see now the difference. That now we have Rails Gateway deployed, and it would be available now for object storage use. This was before.
Okay.
Yeah.
Did you add an OSD? What else? You did something else too, right? There's Rails Gateway and something.
Yeah, adding, as you mentioned, adding OSDs. No, so let's say that we were running out of space and that we needed more OSDs. Not really adding more OSDs is adding more raw space to our cluster. No, so as you can see here, what's going on is that currently we have 3 OSDs. So in each of our hosts, we have 1 OSD. But here you see that with the change that we applied, no, the Ceph is working, or let's say that Rook or ODF is working on adding 3 new OSDs. No, the only thing that this takes a little bit longer. Let me just check with the status.
Okay, but the dependencies set up in SyncWave still have to be obeyed, right? No matter if you change something, that then everything gets followed. Okay. All right,
that's right. Each time that you press sync, it will go through the full tree, to check everything. So the only thing the things that are in sync won't be modified, but it always follows the full tree of the wave syncs that you just mentioned.
Okay, and how does what is Argo CD, the dashboard show? Oh wait, they're up now. They're done already, right? Okay. Yeah, I was just wondering, like, it shows a different icon or something in the UI when something's progressing, right? Like,
yeah, you can see that it's blue. So, for example, well, we were a little bit late, but when something is out of sync, it goes yellow. When it's working, in getting something ready, you can see that the lines are blue. And when something is in an error state, it goes red. So if you get an error that you can also perfectly get an error, it will go red. So with the colors you have here, in these codes, you can see what's going on. There's many nice things in the UI, that we don't have time to explore. But for example, you can have a look at the location of all of the pods that have been deployed or the objects in the different worker nodes. So there's some really cool things to check here. You can also filter to whatever you want to actually see, because there are loads of objects, but maybe you want to see X, Y, and Z that are more important to you. You can also go through that. But yes, as you mentioned, our OSDs are up and ready. We can see that they are ready to use. So we would already have more space for our developers to use, and everything will be fine and ready. So that's more or less what we had, and more or less on time,
Yeah, perfect. So that's amazing. Actually, I'm really impressed. Like, and certainly how you would manage a real production cluster and make your life easier. So are there some links that I need to get so I can drop them in the description of this video? Maybe templates and things like that? Okay. Awesome.
Yeah, I think I will send you the repo that I'm using. Again, this repo is just an example. It doesn't mean that people have to follow it as it is. But maybe to get it started is a good point. So we can certainly share in the link the GitHub repo that will get you started.
All right. Okay, so it's the top of the hour. I just thank you so much for coming back, and I hope to have you again. We'll come up with something new. And I want to thank Stephen Wilson. He couldn't join us again, but that's okay. He helped to get all this going. And I'll drop the links in the description and take any questions from chat when this goes live. Thanks so much.
Thank you. Thanks a lot, Michelle. Bye.
Okay. Bye.